Hi everybody, welcome back to another MyTutor online school tutorial. Today GCSE Maths, and we're looking at linear and quadratic inequalities. Exciting stuff. So this lesson is 1 hour long, so it'll finish at 12 midday. And this is me, Molly, who's running the session. Most of you, if you've been here before, know me by now. Just finished my second year studying computer science and maths at Bath, and I've done loads and loads of lessons with MyTutor before. Which hopefully means I know what I'm doing. So a couple of things to say, but whilst I'm doing that, let's get joining on the Kahoot. So I'm going to do this Kahoot at the beginning. It's just 7 questions long, and then a similar Kahoot at the end to see if there's a difference in how much people could answer. Whilst people are joining this, either go to kahoot.it or the Kahoot app. Just to say, after this Kahoot, I'm going to be doing another poll like yesterday to get answers to what time you'd like the new sessions to be at once schools go back and everything. If you've answered it before, just answer again. We're just making sure we get as many results as possible. So that would be really good. So we'll see that again today. Throughout this session, if you haven't been here before, even if you have, make great use of the chat and Q&A functions. I always point up there. I don't know if they're up there for you guys as well. Anyway, because I like to know that you guys are following, that I'm making sense. And also it just helps you if you have somewhere to put your answers and check. Yeah. So we'll get going with this once a few more people have joined. So today's topic, inequalities. So linear inequalities, easier than quadratic inequalities. So we're going to start with those, but we'll cover both. We'll basically see that a lot of the way in which they work is quite similar to if we just have a regular equation, but we'll look at what the differences are, how to represent those on a number line, and then quadratic inequalities, which are harder, but I think they're quite fun. So, we'll see. So I'll just give this a couple more minutes for people to join before we get started. Okay, I don't think anyone else is. I mean, there are other people in the webinar. Oh gosh, we're dropping in numbers in the Kahoot. So I'll just listen here. So you can join whilst we're running the Kahoot. I don't lock the room or anything. So just join whenever. So question number 1. So with inequalities, we get solution sets. There's not just one solution. So the solution set to this. So if you're not sure, give it a guess, or maybe try to work it out based on what you do know, or just leave the question. Whatever you want to do. This is just for you guys to have an introduction to the topic, see the kind of things you'll be able to answer by the end of today. Okay, I think that's everyone who's in here. Okay, cool. So most people still got the answer right. So I won't be showing, I won't be going through these ones, but we'll see very, very similar questions in the lesson. Just because there's no point in me, if I start explaining these, I'll basically be teaching the whole lesson. So these are just quick ones. Okay, what about this one? Okay, I'll wait until, so last time 15 people answered, so I'll wait for about that. Okay, really tricky one that. And these 5 people here who put that one, you're super, super close. And I know exactly where you went wrong. And this is a difficult one, but it's just one little rule to learn. And we'll discuss that rule in the lesson. Okay, now the reason that we've got a factorizing question in here is because you need to factorize in order to answer the quadratic inequalities questions. See, factorize, it crops up everywhere. So, okay, yeah, awesome, yes. Factorizing people can do, I love that, nice. Okay, another factorizing one. These people got that one, so let's see how many can get this one. Okay, awesome. Again, loads. Slightly fewer people, but I completely understand this. The only place that people went wrong here was putting the numbers the wrong way around. What this will give you is x squared plus x minus 20. So super, super close. It's just checking which way around the numbers go there. Okay, and then a factorizing with a larger coefficient of x squared. So what about this one? We did go over this, I think, last week, maybe the week before. So if this is difficult, maybe check that one out, or yeah, just give them a practice. Once you factorize loads, you get a lot better at it. I'll definitely give people more time on this because it is a tricky one. Cool, loads of people got that. Luckily with multiple choice, you can expand out the answers and see which one fits. But we will be looking very briefly at how to do ones like these, but we're not going to focus too much on factorizing today because that's not the main point. So I'm glad that people have understood these really well. That's really encouraging. Okay, so now we want to solve this quadratic inequality. If you've not seen this before, this is going to be really, really hard to do. So if you have absolutely no idea, either leave it or guess. It's up to you. But don't worry if that looks like absolutely impossible to you. As I said, I think these are interesting, and I'll show you what I like doing them. They're a nice process. I don't think you guys will hate them, so we'll see when we get to them anyway. Okay, I'm going to stop the timer. Oh, no, I won't. It will stop for me. Okay, yeah, very difficult one. I think that's just some guesses there. So the next one will also be guessed. X squared plus 11x plus 30 is greater than 0. Honestly, I'm quite glad that you guys I don't know these ones as much because I know that you can definitely all learn how to do them by the end. So that's exciting. Yeah, to be able to teach you something. So I'm only going to, well, no, I'll just wait till you've all pressed something. If you haven't by the time ticks down to 40, I'll skip to the next. Okay, so again, a very, very difficult one there for people, which is totally fine. Makes sense, in fact. So, okay, let's have a look at the podium. I feel like this is a podium of guesses, potentially. But Lilac Falcon, well done. You guys may have seen the topic before, be good at working out. Bob in second. And 5 out of 7 is either some very good guessing, or you have seen it before. QQ, well done. So let's take a look at the average percentage there. And hopefully it goes up by the end. It's only gone down 1 week that we've been doing the Kahoots, so we'll see. 34%. So we'll keep that in mind, and hopefully we get more than an average of 34% at the end. So, okay, let's get going with the content for today. So as I said, I'm going to start with linear inequalities, explaining what on earth those are, displaying them on a number line, solving them, then quadratic inequalities. So, an inequality is basically just a range of values that something can be. When we say x equals 2, it's a very specific number. But when we say x is less than 2, x could be 1 or 0 or minus pi or anything. It's a range of values. So displaying these on a number line is a really, really helpful way of not only visualizing it, but also kind of showing your answer. And there's just a method that we use for doing this. So the thing that we do is an open circle represents less than, and a closed circle represents less than or equal to. So for example, the inequality x is less than 2, as I just said, we represent that by having a number line, we mark 2, and then we say it's less than 2. So it's an open circle, which means it can't be equal to 2. We call this a strict inequality because it's strictly less than. And then it's anything that's less than 2. So x can be anywhere along that line, tending right down into infinity. Someone said, do we have to do the number line? No, some questions, if you are giving a solution set, just writing x is less than 2 is totally fine. Some questions, as we'll see, will specifically say, draw this inequality on this number line. So you do need to know how to do it, but you don't have to do it if it's not asked for. Let's have a look at a couple of others. So let's say we had x, helps if I have the pen, x is greater than or equal to 1. We have our number line, we mark 1, wherever that may be, it really doesn't matter. And because it's greater than or equal to, it's a circle. And there's our line going off. We drew a little arrow just to show it's going into infinity, because infinity is greater than or equal to 1. And then we can get some cool ones. For example, if we have x, so we have x is between 3 and 7, but it could be equal to 7. So x could be 4, 5, 6, 7, can't be 3, and it's got to be between these values. So what we show here is if we mark 3 and 7, well, it's strictly greater than 3, but it's less than or equal to 7. So this one is a shaded one. And it's between these two values. And so what we mean is that x is represented on there. Some people are saying they're confused. Well, it's either some people or the same person. I can never tell on the Q&A because it's anonymous. I'll do a couple more examples of these. All it is you just mark on the number line the numbers that it's between with circles and connect them, shade it if it's an equals to. We're just showing the someone said, isn't the arrow the wrong way around for the examples? No, so we're showing where x could be. So here, x is less than or equal to 2. So for example, the number 1 is here, and that's certainly less than or equal to 2. So we're saying anything along here. So this is a very difficult question for you to answer, but I'll give you a few seconds if you maybe want to write it down or think, but you don't have to type anything. So what about if we have x is between -4 and 1, but it could be equal to -4, but it's strictly less than 1. Have a go at either drawing that yourself. Yeah, someone said, does a closed circle mean the number is equal to or less than? Yeah, exactly right. Closed circle is less than equal to, open circle is just less than, or the other way around, or greater than equal to, greater than. So I'll just give you a bit. It's difficult because I don't know how many people have answered because obviously you can't type a number line. So I'll go through this one now. So here's our number line. First thing that we do is we mark our numbers, -4 and 1, and then draw our circles above them and connect them. And then we connect it up to it. And then we just see, well, it could also be equal to 4 because this was a less than equal to. So this is a closed circle here. And that's all there is to it. We're literally just drawing these here. Okay, what about, I'll just do one more for mine and then I'll do some on a sheet. What about x could be less than or equal to 2, or x could be greater than 10. So x still has a distinct range of values, but this time there's kind of a gap in the middle. It could be in 2 different places. What do you think this number line will look like? Give it a go. I'll give you about 30 seconds and then I'll draw it myself. Okay. I think people are done. Someone said, is it a two-step inequality? Yeah, kind of, because it's 2 distinct things. I'll show you one here. So again, we mark the numbers 2 and 10. Doesn't really matter what scale it's at, but this is our own number line. And then x is less than or equal to 2. So it's less than or equal to, so it's a closed circle. And it's less than or equal to 2. Or it's greater than 10. So this is what this number line looks like. Yeah, greater than or equal to is closed, just greater than is open. Exactly right. I would think of it because it's anywhere on this line that x can fall. And when it's an open circle, it's not part of the line doesn't go through it, whereas when it's closed, it kind of does. That's how I remember it anyway. Someone's asked for a key. Yeah, that's a good idea actually. So just key bits of like terminology and stuff today. So this is greater than. So whatever's on the left is greater than that on the right. That's greater than or equal to. And the same with the less thans. This represents greater / less than or equal to. And this represents strictly greater or less. So these 2 are linked and these 2 are linked. Hopefully that makes sense. Okay, let's go on to the ones on the sheet because we do have quite a lot to get through today. So for example, this is one that you can write down to really understand this concept of inequalities. So n is, so -1 less than or equal to n less than 4. N is an integer. An integer is just a whole number. -5, 7, 22, those are all integers. So what are all the possible values of n? Give it a go, pop it in the chat or the Q&A. Oh, that was an error. I don't know how I'd manage that. Okay, a few people are there or close to it, which is really good. So the answer to this one, so remember it can be greater than or equal to -1. So there's our first one. It could be equal to -1. And then we count up until we get to 4. So it could be 0, 1, 2, 3. Can it be 4? Well, no, because this doesn't say less than or equal to 4. It just says less than. And 4 isn't less than 4. So this is the solution. -1, 0, 1, 2, and 3. Hopefully that makes sense. Okay. I am going to move on to some ones with like some algebraic ones. Just because I think it is slightly different from this. So even if you don't understand this, I think you'll still be able to follow the linear ones. And I want to make sure we have enough time on quadratics. So I am going to move on. So something like this. Solve 3y minus 2 is greater than 13. Now, the key thing is that these work almost exactly the same as an equal sign. Don't be thrown off by this. It's going to be really, really, really similar to if it was an equal sign. The only difference, and this is what I talked about in that first Kahoot when people got the answer slightly wrong, is that if you multiply or divide by a negative number, the sign flips. And I'll show you some examples of that. The reason is, if you think about it, if we think about the fact, well, 1 is less than 2, right? However, what if I multiply that all by -1, i.e. -1 and -2? Well, -1 is actually greater than -2. Because once you go into negative numbers, the smaller the actual bit of the number, the bigger it is. So this is all you need to know to realize that if you multiply or divide by a negative, the sign flips. So any time with an inequality, you multiply or divide, think, is this a negative that I'm doing it by? If so, flip it. And we will see some examples where that happens. So in this one, we're actually not going to have to do that. So we're just going to solve it as though that was an equals. So we want to get just y on the left-hand side. So we're going to add 2 to both sides. So we get that 3y is greater than 15 by adding 2. Then we're going to divide by 3. Now check. Are we dividing by a negative? Nope, we're dividing by a positive 3. So everything's fine. The sign will stay as it is. So 3 is greater than 5. 3 is greater than 5. Y is greater than 5 because we've just divided by 3. So hopefully that makes sense there. Remember that you don't have to, don't be put off by the fact that it's not an equal sign. Okay, before I forget, we're going to quickly do the poll because I think everyone's here that's going to be here. So just let your brains digest that. And even if you voted, do vote on this before. This is just next week. We're going to have online schools tutorials, but just fewer of them. So we want to know what times people would prefer that to be because schools are going back. Yeah, I guess we'll see. And even if you have voted before, just do it again. We know that. Oh, that is a good point. Someone said, can you add the option of I don't mind so people who aren't bothered can vote? I don't actually think that I can change this poll now. If you do have a preference, even a slight preference, go for it. If not, I guess just don't vote. That's okay. Okay, I think everyone who is going to vote will have voted. Okay, cool. We'll end that there. Okay, thank you guys. Okay, fab. Right, let's go on to another question. Let's do this one here. Oh, keep clicking on the wrong tabs today. So let's have a go at this one. So give it a go. Just write your answer as P greater than or less than something. Pop it in the chat or the Q&A. Let's see. Someone said they couldn't see the poll to put it up again, so I'll just... Oh no, apparently if I put it up again, it will clear the existing vote, so I'm afraid I can't. But enough people voted, so don't worry. Cool. Loads of people getting it, which is really fantastic. So let's have a go. Remember, just do this as though it was an equal. So we want P by itself on the left. So we're going to add 7 to both sides, which is going to give us 3P is greater than 18. Then we're going to divide by 3. Now, are we dividing by a negative? No. So we're fine. The sign stays the same. So P is greater than 6. Simples. So well done. Loads and loads of people got that. So let's have a go at gosh, I might have to come up with my own. Because I know, yeah, okay, right, I'm coming up with my own. Let's solve the inequality. 8 minus 2x is less than or equal to 6. Okay, give this one a go. Let me know what you get. You can just write it when you type it, just write greater than if you need to. I know that you'll mean greater than, sorry, less than or greater than or equals to. Okay, let's give this a go, shall we? Okay, so we want x by itself. So the first thing that we'll do is get rid of this 8 because we don't want it there. We want it on the other side. So we'll subtract 8 from both sides. So we get minus 2x is less than or equal to minus 2. Now we want x by itself, so we'll divide by minus 2. Now, ding, 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 we're dividing by a negative number. So we've got to flip the sign. So dividing by negative 2, we know will get us a 1, because negative 2 divided by negative 2 is 1. But this sign is flipped. So x is greater than or equal to 1. And lots of people got that, which is really, really good. So well done. Okay. Only other thing that I want to go over, we'll do one last question on this before we move on to scary, scary quadratics, is one like this. Let's say, gosh, these numbers might be horrible, and I'm sorry if they are, just because I'm coming up with this on the spot. 2x minus 3 is less than x is less than 5 plus x. No. Okay, no, wait, no, I don't want this question. We're just going to go for numbers. We're going to go for 14 is less than 2x is less than, okay, yeah, we can do this. Is less than 20. We'll just do one like this for now. This is fine. And I'll do one more after this. So the thing with these, all I'm trying to show you, which is why I suddenly realized I didn't want to overcomplicate it, is that if we have certain things, so here we're saying that 2x is between 14 and 20, is what this is telling us. No need to overcomplicate it. We want to get x by itself in the middle, so we divide it by 2. So just divide everything by 2. So we have that x is between 7 and 10. And that makes sense, because if x is between 7 and 10, then 2x is between 14 and 20. Sorry, just trying to keep on top of the Q&A. So what about if we have, minus 6 is less than 3x plus minus 4 is less than 3x plus 2 is less than 11. Gosh, that took some thinking about to make sure that the numbers are going to be right. Again, we're going to do exactly the same thing. We want to get x by itself in the middle. So what do? We subtracted 2. So we're going to subtract 2 from everything, all like the parts of this, and then divide by 3. So we'll divide by 3 on everything. So we see that x is between minus 2 and 3 for this one to be true. Okay, let's move on to the quadratic inequalities, because I do want to have time to cover that, and we will be doing the other Kahoot in about 15 minutes. So if you don't fully understand this yet, that's totally fine. These videos are recorded and on the MyTutor YouTube channel. So watch it again, watch me at half pace, twice pace, whatever. Yeah, whatever you want to do. Okay, let's move on to the quadratic ones. So the quadratic ones, I'm just going to dive straight in with an example because I think it's the easiest way. First one that I'm going to do is an easier one just to show you something. So if we just have x squared is less than or equal to 49, what do you think the solutions are to this? Yeah, cool. A lot of people have got it and seen the trick. Yeah, so we square root both sides. Now the key thing is that when we square root something, we get 2 solutions. If you square root 49, you get plus or minus 7. But if we just did that here, we'd be saying that x is less than or equal to 7 or less than or equal to minus 7, and that doesn't really make much sense. So what we're going to do here is something quite sneaky. And we're going to think, well, let's draw a graph of x squared. Looks like this, right? And 49 occurs here, let's say. And that occurs at minus 7 and plus 7. Nothing too radical right now, right? We've just drawn a graph and shown where it's equal to 49. Now, this graph, this black line here, is x squared. So where is that less than or equal to 49? Well, it's underneath this bit here. So it's anything underneath this line. Therefore, it's between minus 7 and 7. So our solution for this becomes this. And that makes a lot of sense. If you're squaring something to get something smaller than 49, you want to square anything between minus 7 and 7. Right? Because otherwise, if it's anything bigger than 7 or smaller than minus 7, you're going to square to something like 64 or 81. Someone said, can you do it without the graph? Yeah, you definitely can. You definitely can just kind of think about this. But this graph is going to help us for the more complicated ones. So I think it's good to get into the habit of using it now. But if you can just see it, like without doing the graph, it's totally fine just to write that answer down for simpler ones like these. I definitely think that the best way that I can explain it is by demonstrating it on a graph for you. So that's what I'll be doing. So what if we had x squared is less than 16? What's the solution to that? Yeah, cool. A few people guessing it. So again, here's x squared. Where is it? 16 here at minus 4 and 4. And we want anything less than that. So we want x being between minus 4 and 4. I think once you've done a couple, there's nothing too difficult about these. It's just a different way of thinking. It's not quite like solving an equation, is it? You've really got to think about what it is that you actually mean. For example, what if we had x squared is greater than or equal to 25? What do you think we could have here? I definitely recommend drawing the graph if that helps you. Somebody said, is this the hardest that it gets? Unfortunately not. However, once you understand the way that we apply the graphs here, the next thing that I'm going to show you won't be as hard as it looks. And we'll see why. Okay, so I'll go through this one. So let's just draw x squared. Oh, that was very bad. It should be touching here. And see where it is equal to 25. Well, up here at minus 5 and 5. Now we want where x squared is greater than that. Where is it greater than it? All the way up here. And where is that true? Well, outside of this boundary. So less than or equal to minus 5 or greater than or equal to 5. We've got our two kind of, yeah, it's not between it, because if it was between it, it would be less. And you can think about some real examples because, you know, we've got the 10 squared, say, well, that's definitely greater than 25, as is minus 10 squared. So squareds are always really, really interesting because of this shape. They're always going to be weird, slightly different inequalities because you can have two solutions for everything. So let's have a look at how to do the most complicated one that we can get, which I promise still isn't too bad at all. So we want to, let's solve this inequality here. No, let's not, because that's too hard to factorize for the first one. Let's solve this inequality. Okay, x squared minus 3x minus 4 is less than 0. So, remember earlier I said that we were going to be using factorizing? Here it is. Here's where it comes in. So, don't be overwhelmed by this. Just pay attention to what I'm saying. I promise this is nothing that you can't do. So the first thing that we're going to do is we're going to factorize this quadratic. So pop in the chat, what do you think you get when you factorize this? Yeah, perfect. A couple of people have got it already. Yeah, awesome. Someone said, is this the hardest that it goes? Yes. These ones are hardest, where you have to factorize and then do it. Inequalities wise, I don't think it could get worse than this. Not that this is bad. I don't mean to make it sound like these are impossible. But if you can do these, you're super, super set. So the way that this factorizes is into x minus 4, x plus 1. Now, if you don't understand how to factorize that, I'm unfortunately not going to be able to go over it now because I want time to explain the inequality side of things. So just accept that that's what it is factorized and maybe go off and research it yourself. Check out, I've done a couple of tutoring sessions on it, so you can always check them out. But yeah. Okay, so now what we do is we're going to find what are called the critical points, the critical values. And this is where we imagine for a second that this was equal to 0 and think, well, okay, what would the solutions be? So does anybody know if this was equal to 0, what would the solutions be for x? Yeah, a couple of people got it already. Fantastic. Okay, a few people have got it. I will explain why this one is the answer. What we think is that when this is equal to 0, the only way that two numbers can multiply to make 0 is when one of them is 1. You know, can you think of any two numbers that multiply to make 0 where one of them isn't 1? Isn't 0, sorry. No, because it's not possible. What that means is that one of these brackets has to be equal to 0. And by setting each of them equal to 0 is how we find our two solutions. So I'll do this part in grey. So we're saying x minus 4. I'm doing it in grey because it is not part of the actual solution. We can't just change this to an equals. But we're saying if it was, what would they be? And this will help us. So if this one is equal to 0, you get that x equals 4. And for this one to be equal to 0, you get that x is minus 1. So these, back to the actual bulk of the question, we call the critical values. And the reason is because if you're trying to find something less than or greater than 0, if you know where it is 0, you can help yourself a lot. You know, for example, if you're trying to find out in the previous one where something was less than or equal to 49, we marked where 49 was, and then we knew whether to look above or below, like what line we were looking at. So what we're going to do now is our favorite thing to do, and we're going to sketch this quadratic. Now, obviously, this is not just an x squared graph, so we can't just sketch it as we were before. But, and this is the bit that's super, super useful, is that those critical values tell us where it crosses the x-axis. Now, the reason is because where something equals 0 is where these values are where where y is equal to 0, and y is equal to 0 on that x-axis. So what I'm saying is that this graph is going to look like this, where this is minus 1 and this is 4. Because when you plug these values in as x, you get 0 for y, so you don't move up from the x-axis. So this is why we find the critical values, because now we have a sketch, which is fantastic. And we know that this line here is 0. Just like on this one, we drew our line for 16. Now, because we're looking at less than 0, we've drawn our line for 0. It's just the x-axis, and we know where it crosses that. So now what we want to do is work out which part of that curve we want. Well, we're looking for this inequality to be less than 0. So we want everything less than 0, underneath 0. Simple as that. So we want anything that falls here. So what we're looking at is any part of the curve that falls underneath the x-axis, which is clearly just this bottom part of the curve here. And where the points fall there, well, anywhere that those points are between minus 1 and 4. And that is your solution to this inequality. Does that make sense? Let me know in the chat and the Q&A if that makes sense. Or if it doesn't, what about it doesn't make sense, so that I know how to explain it better. Okay, makes sense to some people at least, which is promising. Okay, people are saying they understand it a bit more, which is good. I'll go through one example and try to explain it just as slowly and clearly. See what people are saying here. Okay. I think for most people it makes sense. Let's go through another one though, and I'll explain it just exactly the same as I explained that one. Let's do, oh gosh, okay, none of these are, luckily I have this open, so we can find another one. Oh, I don't have permission to access this resource. Interesting. Should I just come up with one? Oh no, not to worry. Let's do, gosh, no, these are not what I want. I'll just come up with one. Okay, let's do x squared. Okay, give me a second. Minus 5x plus 6 is less than or equal to 0. In fact, let's do greater than or equal to 0 because the last one was the less than. Okay, so just remember this. Factorize, critical points, graph. 3-step process, that's all there is to it. So let's start off by factorizing. What do you think we get when we factorize this? Okay, I'll just go through this because as I said, it's not the main point, but that was just to give you a chance. This will be x minus 2, x minus 3. So you can check that you believe me by expanding it out yourself if you want to. Okay, so what are the critical points going to be? If this was equal to 0, what would the solutions be? Pop it on the chat or the Q&A. Oops, clicked the wrong button, don't mind me. I'm surprised I haven't done that before actually, because the stop share button is so close to the chat. Yeah, brilliant. Okay, 2 and 3. So the critical values are 2 and 3. So now all we do, this step is not as confusing as it seems. We just draw a positive x squared curve going through the points 2 and 3. Now we want it to be greater than or equal to 0. So it's the stuff above the axis, greater than or equal to. So it's these parts of the curve that we're looking at now. And where do those occur? Well, either when x is less than 2 or when x is greater than 3. Because anything in between gives us a value that's less than 0. So we don't want anything in between, we just want the stuff on either side. Now you can answer any question to do with this. The only thing that you've got to remember, and one thing that it's a shame that we didn't get around to, but maybe in the future, is when you have negative quadratics, the only thing that changes is that you draw the curve upside down. It's a sad face instead of a happy face. Still think about what are your critical values and what does that mean for the range of x. So we'll do the final Kahoot now. So what I'll do is whilst people are joining this, let me know if you have any questions or need anything re-explaining. So there's the Kahoot pin. But do let me know. Does that make sense? How much sense does it make? Are there any parts that are still confusing? Still confusing you? Someone's asked what the next webinar is. I can't remember what the next webinar today is, but it will be at 2. No, there's one before that. 12:15? Is there one? No, one at 2, right? I think. I'm not 100% sure, but there is a schedule on the MyTutor website. My next one is tomorrow. Cool. And someone said, why are there 2 maths tutors? Just because I do higher stuff and they do foundation stuff. That's all. Because maths is such an in-demand topic. Obviously, because it's so cool. Sure, someone said, can you re-explain the last question? I don't understand why it's greater than or equal to. Sure thing, because this won't take me too long. I'll pop this in the chat. Please do keep joining. As soon as I've answered this question, I'll start the Kahoot. So there's the code. So the reason that it's greater than or equal to is just because that's what we were given in our original question. You just see whether that's a strict inequality or an equal to equality, and then we do that. The reason that we went above this curve is because it was greater than or equal to 0. So we look at everything above here, and then we see which parts of the curve are above there. Well, it's these parts. And we can only access these parts when our x value is either somewhere over here or somewhere over here. In the middle, we can't get to those parts. In the middle, we get down here. So it's not greater than or equal to 0. So hopefully that makes sense. Okay, I'm going to get going here now. because I want to make sure that we have time, but do keep joining whilst I'm running. Only 6 questions in this one. There was 7 at the beginning, so you know, you've got it easy, really. So what's the solution set to this? So hopping back to a linear one, but it's a horrible linear one because you've got some fractions to deal with. So hopefully this is a nice challenge. Maybe this is why the percentages don't always go up so much. I always throw you some horrible ones in the final Kahoot. But oh well. Give you guys a little minute for these ones. Someone said we didn't learn this. Yeah, so we didn't do it with 2 x's, but all you've got to do is imagine that was an equals. You know how to do that. So just remember to just move this x to that left-hand side. So expand it out, move the x's to the left, keep the numbers on the right, and simplify it. From the stuff that we've learned today, you definitely can do this one. I believe in you. Okay, I don't know if anyone else is answering. Once it gets down to 30 seconds, I'll skip so that we have time to do them all. Oh, difficult one that. Okay, that's fair enough. I'll quickly go over this one then. I think I should have time to go over this and still get through the rest. So with this one, I would actually start by multiplying everything by 6. And the reason is because if we multiply everything by 6, we get rid of both this half and this third. So we're going to get 3x is less than or equal to 2 lots of 2x minus 6 plus 3. I am doing this fairly quick. Oh, not plus 3. That's going to be times 6. Plus 18. Then I'm going to expand out these brackets. 4x minus 12 plus 18. I am doing this quickly. Subtract the 4x and combine these here. Oh, I'm writing less than equals to. I just mean less than. Subtract, so this gives us minus x is less than 6. And then we're dividing by a negative, so we flip the sign. So x is greater than minus 6. So sorry I had to go over that quite quickly, but do give that another watch and another go on the YouTube video if you get a chance. Let's have a go at another one. Okay. Now this is kind of a horrible one. I really did throw you guys in the deep end here. Maybe I should have popped a an easier one on here. However, you know, I'm just challenging you in a really horrible way. Try moving all the x's to the left and the number and the non-x's to the right and factorizing an x out. Oh, well done. Well done, guys. That was well answered, actually. Yeah, so we have to move the cx over here. Now, the reason that we have to know a is less than c is because we'll factor out an a minus c of x over here. So that means that a minus c is negative, so we have to flip the sign. So that's why they told us that piece of information. So really well done if you got that. Okay, let's do a factorize. Hopefully this can bring up our percentage. So even if you know what the numbers are, think about which one goes in which bracket. Okay, I'll let it go down to 30 seconds and then skip so that I have time to do all of them. Oh, cool. Well done. Yeah, well done, guys. Nice. Yes, again, these 5 people here, so close. You got exactly the right numbers, but that would make x squared plus 3x minus 18. So super close. Okay, have a go at factorizing this one with a horrible large coefficient of x squared. I can really feel the percentage going down on this one. What did we get at the beginning? 34? I think we could be lower. But it's harder questions, so I don't mind. I won't be disheartened. I'm only going to let this one go down to 60 seconds. Someone said, my math teacher said it doesn't matter which way around the numbers go. That's true if the signs are the same. But if the signs are not the same, it does matter because you get a different result. Okay, cool. Yes, well done, guys. That was actually super well answered considering it's got a big coefficient. So really good job. Okay, 2 horrible ones. Some quadratic inequalities. Remember, factorize it and find those critical values. Draw it. Even if you just find the critical values, you can narrow this down to 2. Are they -1 and -7, or are they 1 and 7? So give that a go. Try drawing it and see if you can work out which way it should be. I'll probably let this go down, seeing as we only have one more after this. I'll let this go down to 0 to give people a chance to answer it. Okay, if everyone's, sometimes it automatically skips, so I don't think everybody's answered it yet, but we'll, there's only 7 seconds left. Let's see. Okay, nice. That's definitely a bigger percentage for these ones than there was at the beginning. So really good job. And the people that put this one here, even though your critical values weren't right, you knew that because, well, or maybe it was a lucky guess, but it was less than 0. So it's sensible to guess something within a boundary, rather than outside the others. But really well done if you did get that. And finally, a horrible one to factorize, but looking at the solutions can help you work out how to factorize it, to be honest. So just because it's just turned 12, so I'll try not to run it over anymore. So I'll just let this go down to 60 seconds. So I'll shut up and let you work. Has everybody got their answers in? Does anybody want me to leave it, or shall I skip now? Okay, no one said anything, so I'll go. Oh. Okay, skip. Cool. Okay, cool. That's really good. I'm just trying to see what the other one. Yeah, so the other one that was really highly voted as well was at least the right critical values on here of these. So awesome. Yeah, the only reason is because it's greater than 0. We know it's going to be split into 2 inequalities. So yeah, really, really well done for getting through that. Lion, Falcon, Lilac, 4 out of 6. Very good. Bob, 4 out of 6. And in first place, 4 out of 6 is the Black Heart. Cute. So let's see. Oh gosh, I feel like this has definitely gone down from earlier. So maybe I shouldn't even check this. It was 34 earlier. Come on. Oh, so close, so close. So I think that's just down to the fact that I chose very hard questions for the end. So I'm still super, super impressed with you guys. Well done. If you even followed the tiniest amount, I would say for quarantine, 11 a.m. is still pretty early. So well done for even making it to this. You should all be very proud of yourselves. So thank you very much for coming. I've got to finish on a joke. Someone sent in a really good one because it relates to today. So why was the equal sign so humble? Because he knew he wasn't less than or greater than anyone else. It's an inequalities joke. Amazing stuff. Love when they're topical. So do check out the MyTutor website for the schedule about what's coming up later today and over the next few days and stuff. And all these videos are filmed and put on the YouTube channel, so check that out. MyTutor also offers one-on-one tutoring, which can be super useful maybe if you're not going back to school yet, if you're in one of those years that's been missed or so on. So I will personally see you guys again tomorrow for some more maths fun. Thank you all for coming, guys, and really, really well done.